first, let's have a quick overview about the book itself. So I will bring it up. And there's a preprint version. That's why I can't show you the title page, but you see that in the images for the events, right? So let me go into, and let's quickly go through the index to show you what the book is about, the table of contents. So the book has 4 parts, and this is the first part, memory in C++. You may think this is very basic, which is true, but it's also very detailed knowledge where Patrice shows his knowledge about how things basically work in the machine of C++.
Yeah, it's basic, but I don't think the people really know that stuff are very few and far between. I'm lucky that I've been involved in the core working group for 10 years now, those who write this thing. And even then, I'm hoping that I didn't make any mistakes there, but there's some deep stuff. And there's stuff that is moving a bit these days. We're sometimes rethinking things in C++. We changed the meaning of the restrictions tied to integers just recently. So this is not a language that has stopped moving. We're trying to do things better. The very idea of a byte, say, is currently at least 8 bits, something that is big enough to hold a Unicode character or something like that. I don't remember the exact words. But that might stabilize on exactly 8 bits sometime in the future. There's discussions about this. So there are moving targets there, and sometimes very, very subtle. I wanted to make sure that we had a common vocabulary and a common understanding of some of the basic and essential concepts before you start working. So that's why I wrote this first section. And you might notice, especially with the page that you're looking at right now, chapter 2, it's filled of stuff you shouldn't do. And I felt kind of weird writing a chapter like this, like, don't do this, please. But my point was, in this book, by definition, we sometimes have to get our hands dirty and go low level a bit. So I wanted to make sure that if we did that right. So not trying to do things you're not supposed to do because it kind of works. Maybe C lets it go. Maybe your compiler lets it fly because C does it, but it's not correct, and don't do that. So I wanted to make sure that we had a common understanding of that too before going further. So I'm hoping people don't get rebuked by this when they read the book. It's kind of weird to start the book with "don't do this," but hopefully it will help people get finer standing on what they're trying to do and how to do things, and be able to make their way through the book better after that. That's my hope.
I do think that it's something which really makes the book really good. So I was just intrigued by the special cases of char and std byte. And std byte is something which is rather new in the standard, and a lot of people probably have no idea what it is or how to use it. And so it's like also kind of, memory management gets interesting when you get to be on the low level. And so it's really nice to see that you establish this lower line things.
Well, byte is a C++ 17 feature, std byte, and it was controversial when it came out because if you go back to before C++ 17, the word byte, when you saw it appear in C++ code, it usually came from platform headers like Windows.h or the Unix stuff, and it was an alias for, let's say, unsigned car or something like that. So you ended up with a type that you could do arithmetic on. And now std byte, you can do bitwise operations with it. You can cast it to an integer because it's an enum built on some kind of unsigned car, but you cannot do arithmetic based on it. So people were reacting strangely, saying, "This is not the byte I'm used to." But it was a byte designed to do specific things. We want to, at some point, retire car from its role of being a byte and use something else. But we're not there yet. It's going to take a while, but we're going there smoothly. But in my book, I mostly use car. I think people are more used to car than sign car than to byte.
Yeah, but let's move on from the basics. There's actually part 2, implicit memory management techniques, which starts with, covering destructors, SRC, and introducing RAI, and also going into the smart pointers and the lookout, scope card, discover. This is the things which are the basics of what you're then later building upon. So this
Yeah,
kind of continues what you did in the first part.
absolutely.
And
If you're writing C++ code today, you should be striving for those tools mostly. You don't want to do manual memory management if you can avoid it. You want your files to close themselves. You want your memory to release itself. You want to know who's responsible for your data and your code. So you want to know who's the owner or what are the semantics tied to that. I think it's cool. When I use other languages sometimes and I need to close files manually, I feel awkward doing that in 2025. So I'm hoping that this section of the book
mhm.
is accessible because you will find there things I think most everyone should know how to do or should know they should do when writing C++ code. Maybe take aside the issue of writing smart pointers that might not be for everyone, but at least using them right is probably to everyone's advantage.
Well, let's take a look at writing.
Thank you.
Um, I have to say that like implementing or basically showing the implementation of those smart pointers is probably also very interestingly
Thank you.
for people to just who don't want to write their own, but to understand basically how do they work. Like how does unique pointer actually work, and how does it what are the mechanics of that?
Well,
And
it's one possible implementation because your standard library writers do a very good job, and please use their stuff. But writing one yourself, at least you get a better idea of what's going on there. Yeah.
I am certain that when you would cover the fully implementation details of the standard, your book would be a lot longer. But I think
Yeah. Well, I'm
more.
not planning to replace my library writers. They are very, very good. I'm not trying to encourage knowledge, but please, the standard tools are awesome, so use them.
But like here we go into shared pointer, which
Yeah.
that's then also getting a bit more complicated than what basically a simple, and that's like this, even the simple version of a unique pointer was a few pages, and um,
Well, shared pointers are very tricky, but they're done right in the standard. The thing that people have to grasp when they're trying to write this sort of stuff is, when you write, you're told in school that there's these solid principles in object-oriented programming, and S is single responsibility. A shared pointer, by definition, has two responsibilities. That makes it intrinsically tricky to write. So I tried to give what is in the book works. It's usable, but of course, it's nowhere near as sophisticated as the real stuff is. But it is
mhm,
enlightening, I think, because I've heard people tell me that seems simple. Wait until you try to write it for real. That's fun.
mhm. Well, then we get to the third part, um,
Okay.
which
That's more technical, yeah.
yes, where actually where the content of the book at page 130 actually starts when you want to implement your own versions of like
New and delete and stuff like that. Yeah.
yes, and I think that's again that's like there's before we started the interview I told that I told you that I think that's like the thing about memory management which can be frustrating in C++ is that we are already pretty good with it, and so doing it correctly and being faster in the situation you'd like to apply it to can be difficult, or like just pick a library that has an arena allocator, which I see you have here, arena based memory management and other optimizations in a chapter, and for leak detection we have tools for that, but of course basically understanding how those tools work is again very valuable. um,
The C++ is about control, you know. So the crowd I work for normally, my game programmers, my finances people, my embedded systems people, they,
oh
they,
sure.
they need control over what they're doing. So in these chapters, what I'm trying to show is that sometimes when you know what the context is, you know how your code will behave. You know maybe how many objects you will create at worst. So you know this kind of stuff. Well, you can
Hmm.
indeed do better than the default solution because allocation is not something that accepts a general best solution. That's not how it works. There's some very good average solutions. Your libraries provide very good stuff like already, but when you know what's going on, you can always do a bit better because you can use that special knowledge that you have. So these chapters show that you can, if you do that, measure it. And
Yeah,
we
that's
actually kill orcs there. So if you're a Lord of the Rings person, we're killing orcs in this like any
yeah,
reasonable
also a nice touch. Um, and then we get into writing containers. And today I actually read through the vector example, where you show basically how basically a vector works, and you also implement a forward list here. So you're kind of staying into contiguous containers and not implementing a map or something like that. But yeah, implementing containers is, I think, an interesting topic when you start writing memory managed code, right? That's a different form of memory management.
My understanding is that when you go to school and you try to learn writing stuff, you can write a correct container that works fine for, let's say, integers or floats and doubles. It's going to be efficient enough. It's going to be cool. When you want to manage objects that are non-trivial, things that have destructors that do work and constructors that do work, if you measure the speed of your naive code, compare it with the CD vector, you're going to see that the CD vector is crazy fast because it does a very tight, it has very tight control over memory management and when things are created, destroyed, and everything. So we start with the naive stuff you might know about, and then we see why it's not as fast as you might like it to be, and then we see what you need to do to get there. So this is technical, of course, but I hope it's enlightening. And it makes you appreciate your container writers in the standard library because they actually did that job for you.
Of course, yeah.
But yes, knowing how it works makes a difference if you need that kind of speed and control. I know that my games people they tend to write their own containers for various reasons: integration with their own engines, historical reasons, the way their code base works, and everything.
Yeah, I think
So
it's
I yeah
not everyone has a standard library or wants to use a
no
standard library, because the standard
absolutely
library absolutely does do compromises. So it's not always the fastest or the way you want to have control. And we're
you're
not very
absolutely right.
good in offering the kind of access, especially in the legacy containers and legacy code. Like, containers and algorithms are they're not legacy, but they are very old in C++. And so if we wanted to add something to vector which would break the ABI, you would never see that. And so
Absolutely, absolutely. So yes, so yeah, you can do it. I think is useful. The reason I put forward list there because you're mentioning it is not that I'm encouraging forward list. I wanted to have a node-based container in there too, and I wanted something simple because I go in large detail over
yeah,
contiguous memory because I think that's the gist of what most people reading this book will want to know about. But nodes have their own peculiarities, especially when it comes to containers with allocators. So I wanted to have at least one to be able to discuss those things with people. So that's why you have two kinds of containers that are
mhm.
different in the way they behave, so that I could and go on explaining both kinds of perspectives of memory management.
Yeah, and then like part 4 continues here, and we see you mentioned polymorphic memory resource allocators, which is also historically still a new feature,
Mhm.
even if it's now available for some time. Um, and then you have a chapter on contemporary issues, and then you have a lot of things which are important and people should know about in the annexure. So that's something which is like at the end of the book, but you definitely should take a look at it. So
Yeah, yeah. Well,
let,
I was telling you before we started officially doing this that the when I started writing the book, starting writing the first chapter, I realized how many things people have to know to actually get into the book, and most everyone will know a large part of it, but I doubt that everyone will know all of what they need to know. So I was looking for a way to make that information available. Those
Yeah.
things that if you don't know them, you won't appreciate the book as much, and put them together somewhere. So that if you're seeing the book discusses traits, say you don't know what traits are, you can go there, get the
Hmm.
gist of it, the idea, see some examples. I'll say, okay, I get what's going on there. I'll be able to understand what the book's talking about.
Yeah, I think
And it,
that's really a nice touch
thank you.
to have those basics covered, because that's also often something which people can look up on the internet too. But um, so um,
I hope that it
overall,
helps. The contemporary issues chapter is a bit shorter than the others because it's stuff that is either in the standard but not implemented by anyone yet, as far as I know, or will be in the standard in some form soon. It happens that some of the aspects are like trivial relocation. We just voted it in the February meeting of the C++ standard. So now we know what form it's going to take, essentially. But when I wrote the chapter, I was almost sure where it was going, but we still had competing proposals. So these are things that you will have to read more on to really know what's going on, but at least you'll know it's there.
I've just looked at trivial relocation, and that's really interesting to look into. I know that I could potentially talk with you about it, because there's a lot of different views on this, and I stumbled upon that because I was basically getting interested what's new on class, and I knew that you could say that a class is final, and I was like, wait a minute, why there's two new things coming in 26 that you can say, and these are really long and weird names. I was like, what is this? I never heard about it. And so, and then if you follow the trail, you stumble into relocation and trivial relocation and relocatability. Uh, KDAB has a 5-part series on its
Cool.
blog. I definitely think it's a good read about it. But I stopped doing my research on that because it's very broad and very complex topic at the moment.
Yeah, but what you want to know is that some types, we have copy, we've had copy semantics for a long while, we've had move semantics for almost 15 years now, which is awesome. I mean, when you went into C++11, you recompiled your old code, changed nothing, it just went faster right away because move kicks in. Well, with relocatability, for those types for which a mem copy or a mem move followed by a destructor is sufficient to do the job, vector and such will be even faster with C++26. So we'll hit again a mark where you just recompile your code with your newer compiler, you change nothing, and then it's faster than it used to be. So this is kind of awesome. We had two competing proposals. One was attribute based, and the other one was keyword based. And there was a
Mhm.
fight to the end. Both were interesting. We ended up with the keyword based thing. There were upsides and downsides to both, but the important thing is that we have the feature now. So, and we have to thank all of those who worked on both sides of that fence to get us there because we've been working for a long while on this. I remember having corridor discussions in 2017 about this with people. So it took 10 years to come up. So yeah, we're all very happy that we get that. It's an important optimization feature.
Yeah, and I'm not sure that Saga is over yet. So the next standards proposals meeting in summer
Absolutely.
in Bulgaria will be interesting. But anyways,